Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture we will solve some problem on meta-centric height. In our previous lecture we have seen how to derive the meta-centric height, and in the previous lecture we have seen the buoyancy, central buoyancy, meta-center and meta-centric height. And the last lecture we have derived the meta-centric height. So if you want to see that, you can go for the video and see. Now let's solve one problem on this. So a block of wood, specific gravity. This is the question given. Block of wood is given, specific gravity given, and which floats in water. Determine the meta-centric height. We need to find out the meta-centric height of the block if the size of the block is 2 by 1 by 0.8 meter. So the block may be, okay, it's maybe like this. Let's take, because the height, length and width are both everything is given. So this is the block was there, and the length of this object, let's consider this is 2 meter, and this is the width of this, and this is the height of this. Okay, it's not coming properly. Okay, this is the height of this object. So height is given, how much it is given? 0.8 depth, and this is given 1 meter, and the length of the object will be like 2 meter. Okay, now this is floating on the water, means let's draw this water surface, and this is the object which is placed here. Okay, now this water surface, let's draw like this. Now the depth of this object is, or height of this object is, that is given 0.8 here, 0.8, and this is the width of this object, that is 1 meter, correct, and remaining things are as usual, it is given. Now what about the center of gravity point? We know that this is, let G point, and center of buoyancy will be below to this is B point, and the axis line, let's draw like this axis line, and this point, let it give the A point of this. Okay, now the what are the values are given here, and what we need to find out, the meta-centric height. We know that meta-centric height formula, so that is nothing but Gm equal to I by V minus Bg. This is the formula, moment of inertia, volume and Bg. These three things we need to calculate. Okay, so for that what I'll do, first specific gravity given Sg 0.7. okay, so density we can get 700 kg per meter cube, and dimension is given 2 by 1 by 0.8. okay, so first let's find out the weight of the wooden piece. The wooden piece weight W equal to, we can write rho Vg directly, which is W equal to mg. In the place of m we can write rho V, so we can write rho Vg. So this is the weight of the wooden piece. So weight of the wooden piece we can also write, so value is how much? 700 density. Okay, and the volume is already given, 2 into 1 into 0.8 into G is 9.81. This is the weight of the wooden piece, correct. Now due to this wooden piece inserted into water, so what is the we can say the weight of water displaced, the weight of water displaced. Then both we can do equalize. Now weight of the water displaced we can write same thing again, rho Vg we can write. Now here the density of water equal to 1000, and volume of water you can write like how much, due to this insert of water, this wooden block, how much water was displaced from that. So 2 into 1 into this height. This height means up to this height it was inserted inside the water, so that's why H. Okay, now if you compare this for equilibrium condition, we can write the weight of the wooden piece equal to the weight of the water displaced. So what we can write? We can write 700 into 2 into 0.8 into 9.8. Here also 9.8 will be there. Now here also we can write 1000 into 2, 1 and H and 9.81. Okay, now if you solve this, okay, most of the things will be cancelled, 9.81 here, 9.81, 2 cancel everything. Now here what is the extra thing is there? Now we can write, we need to find out actually H value. So H value equal to, I can write, this is 700 into 8.8, that means we'll get 560, okay, 560 divided by 1000. This side how much is 1000? So that is nothing but 0.56 meter. So this is the total height of wooden block from this water surface to the base after this one. Then what about this center of buoyancy point? That means we can find out the center of buoyancy AB. We know that h by 2, that is half of this object. So that is nothing but we will get 0.28 meter. Okay. Now the total height is how much? 0.8. So center of gravity we can find out A to B, A to G point. Now A to G, this is nothing but half of this object. The distance from this center of gravity to the base point, that is nothing but 0.8 divided by 2. So that will be 0.4 meter. Okay. So now we can find out the value of BG, the distance from the center of buoyancy to the center of gravity equal to AG minus AB. So that will get 0.12 meter. So we got here, see, BG we got, V I got. Now next is I value. I is nothing but the moment of inertia, we know that. So what I'll do, I equal to, let write, I equal to, we can write BDQ by 12. So here with respect to this one we need to consider, so that one we can write 2 into 1 cube divided by 12. So we'll get 1 by 6. 1 by 6 is nothing but we'll get 0.18 something, we'll get it 0.1 40 divided by 6, 0.16, let's write. Okay, 1666 is something we'll get. So this is the I value. Now finally we need to find out the GM, the meta-centric height. So we can write that moment of inertia, or we can keep it 1 by 6. Let's keep it 1 by 6 and into I by V. V equal to how much? Now 2 into this one, 2 into 1 into H. So that is, if you see, I equal to this one, 1 by 4, 1 by 6 into the power 4. That was not written. Now GM equal to, we can write I by V. I equal to 1 by 6 I got, and into what I can write, this one, height of that, volume of that object. So volume is nothing but, we can write 2 into 1 into H. H equal to how much? H equal to, we got 0.56. So this is the volume, that how much is inside the water level. That is the volume, that is the height we need to consider, and minus BG. BG equal to how much we got? 0.12. So 1 by 6 into 1 by this one, 2 into 1 into 0.56. That means 1.12 minus 0.12. So this will get near about 1 by 6 point something will get 1 by something 6 point something will be nothing but 0 point, again same 148 will be there, minus 0.12. So we'll get 0.0028. This is the meter, and this is the value of meta-centric height, GM. Okay. So what is the main thing is there? We need to remember this meta-centric height formula, and we need to know this weight formula, and we need to the concept of like weight of wooden water displaced equal to the weight of the wooden block. Then we can find out the H value, and once we identify the H value, remaining things we can do it easily. So I hope you understood how to find out or how to solve the meta-centric height if these are the data are given. If you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.